using a number line, part 2. Lesson objective: find the distance between 2 points. Before we begin, I'd like to review inequalities. So we're going to graph this inequality. This is saying x is greater than 4. So remember, the Pac-Man is eating the x, therefore x is greater than 4. To graph this, it's a visual way of seeing what numbers make this inequality true. So we go to 4, it can't equal 4, so we put a circle, letting the reader know it cannot equal 4, but we can get as close to 4 as we would like, as long as it's greater than 4. So if you recall, greater than means area to the right, so any number that is in this red region will make this inequality true. Let me bold this a little bit more. So any of these numbers here make this a true statement. These are all the numbers that are greater than 4. Let's do another. Graph x is less than or equal to -2. So now the Pac-Man's eating the -2 is the bigger number. So we want all numbers that are less than -2 or equal to -2. Since it can equal -2, to let the reader know that it can equal -2, we draw a solid dot. So it can equal -2, and then we want all numbers to the left of -2. Okay, so any number to the left of -2 or including -2 will make this a true statement. Let's do one more. This is what we call a compound inequality. So this is red. -3 is less than x, which is less than 5. So we have two inequalities here. Here's the first one. X is greater than -3, or we can say -3 is less than x. If we were to go to -3, and it can't equal -3, so it would be a open circle, and it would be all numbers to the right. Okay. Then the second part of this inequality is this one, and this is saying x is less than 5. So we go to 5, it can't equal 5, so we would put an open circle at 5, and it's all numbers that are less than or to the left. Okay, now what numbers are in between -3 and 5? Well, that's the numbers that are overlapped both in the red section and the blue section. So the numbers that will make this inequality true would start any number that is greater than -3 all the way up to but not equal to 5. So the purple represents the numbers that make this inequality true. Now in statistics, when we start talking about confidence intervals, this is the way confidence intervals sort of look like. We are looking in between two numbers. Let's do a real life example of this compound inequality. And we're going to look at an example at Kings Island. One of the rides at Kings Island is Drop Tower. At 315 feet tall, Drop Tower is the world's largest gyro drop. Drop Tower spins riders on a 30-foot ring of 40 seats that encircles the Drop Tower to a staggering height of more than 26 stories, and then drops guests in a 67-mile-per-hour free fall. So here's a quick little video of Drop Tower. Now this is from Kings Island's website about who can ride Drop Tower. The minimum height is 48 inches tall. the maximum height is 80 inches tall. So you have to be between 48 inches and 80 inches. Let's write an inequality for this height requirement. So the minimum height is 48 inches. The writer must be 48 inches or taller, but at the same time must be less than or equal to 80 inches. So the inequality would look like this. 48 is less than or equal to the height, which is less than or equal to 80 inches. So this is a compound inequality. We have the minimum height requirement. You have to be 48 inches or taller, and at the same time we have the maximum height restriction. You must be 80 inches or less. Lesson objective: find the distance between 2 points. Here we have a series of line segments. To find the distance for FG, that line segment, we could just count 1, 2, 3, 4, 5. Now in some cases counting the distance between the two is not easy to do, so there is another way that we can do this. We can take the highest number, which in this case is 8, and then we subtract the smaller number, which in this case would be 3. So if we take 8 minus 3, we get 5. That is the same number that we got when we just counted. The answer to A, that distance is 5. E.g., E is at 0 to G, that's 8. Well, we could count and we would get 8, or we could just simply say 8 minus 0, which is equal to 8. That is the distance. CF, C is at -4, so this is 4 units below 0, so this distance is 4, and then F is at 3, so the whole distance would be 7. We count 1, 2, 3, 4, 5, 6, 7. This answer is 7. Now, does the trick of taking the largest number, subtracting the smallest number work? Well, let's try it. The largest number, the number to the right, is 3. The number to the left is -4. So again, it's the largest number, subtract the smallest number. Well, the smallest number is -4. So if you take 3 and you subtract -4, well, subtracting a negative number actually makes a plus, so that's the same thing as saying 3 plus 4, and you can check this on your calculator, but the answer again is what we thought, 7. AC would be -9 for A, and then C is -4. Well, again, that distance, if we counted, would be 1, 2, 3, 4, 5. That would be 5, but if we take the largest number, which is -4, and we subtract the smallest number, which is -9, this becomes -4. Subtracting a negative number becomes plus. So this is the same thing as -4 plus 9, and again, using a calculator, you will see that the answer is a +5. Distance is always positive. It can never be negative. It can be 0, but it can never be negative. The last example is AG. So A is at -9, G is at 8. So if we take, I'm not going to count that distance, but if we take 8 and then subtract -9, well, that is equal to 8. Subtracting a negative number becomes a plus 9, and 8 plus 9 is 17. So this distance is 17. Now, why do we want to do this in statistics? Well, there's many cases where we want to find the distance between two values in a data set. This is known as the range. There are times where we want to find what's called a deviation, and that's the distance between two data points. And actually, the z-score formula is x minus the mean. So again, and a lot of times in statistics, we want to find the distance between two data values, and the way we find the distance between numbers is we subtract the two. Let's do another example. Which segment has the largest distance? DF, BC, or AB? DF, well, D is at -1. F is at 3. So DF would be 3 minus -1. This distance is 4. BC, this is at -7. B is. And C is at -4. So -4 minus -7 is -4 plus 7. Well, that is 3. AB, A is at -9. B is at -7. That distance is 2, or -7 minus -9 is 2. So the largest distance would be DF. Thanks for watching.